Okay, now we're going to talk about two main branches of statistics. Statistics could be divided into two other areas. One area is called descriptive statistics, and the other area is called inferential statistics. And to understand these two areas of statistics, you really have to understand kind of the context and how statistical studies are conducted. So let's look at some of that here. I want to first start by talking about the difference between variables and data. Okay? In fact, I'm going to make a little table here. With 3 columns. Variables, data, and data set. Okay? So remember, statistics is being able to collect, organize, summarize, analyze, and draw conclusions based upon data. Okay? So we got to understand, what is this data? Okay? Data comes from observing the value of a variable. Okay? They're measurements or observations that we get by observing the value of a variable. So what is a variable? Okay, a variable is just some characteristic you're interested in, and it varies from person to person in a population. So like someone's GPA, okay, that would be a variable, okay? And if I go from person to person, each person has a different GPA, so it varies from person to person, okay? Now data comes from observing the value of that variable. Okay, so if I go to a particular person, I say, what's your GPA? And they say it's 3.14, or whatever it is. That's pi, 3.14. Whatever it is, 2.78, or whatever. Okay, that's a datum. Singular for data is plural. Datum is singular. And you got a specific piece of data. Okay. And as you go from person to person, and I'm not going to make a distinction between datum and data. I will probably always use the word data, even if I'm talking about a single observation. Okay, but you gather data then by observing the value of a variable. I go from person to person and I collect data. Okay, for example, something that I might be interested in is maybe age of college students. That is a variable because it'll vary from college student to college student as I go through a population. Okay? So the age of college students is a variable. Okay? So data would come if I actually go to a college student and I say, how old are you? And they say, I'm 18. Okay, or I'm 21, or I'm 27. Okay, those values, those are the data, and you get it by observing the values of a variable. So the data would be specific ages, okay, that you would collect. Now a data set is just going to be a set of data. They're just related observations. Okay, so for example, I might want the age of all Hawkeye students. Okay, now I've specified what particular data I'm interested in. And if I go to each college student and I collect their age, okay, and I do it for all Hawkeye students, then I get this big data set. Okay, and it would have all the ages of all the Hawkeye students. And what we do in statistics then is we collect these data sets. And then we can do our statistics. We will organize the data sets, we'll summarize, analyze them, and ultimately we'll draw conclusions based upon the data set. Okay, so the data set gives us the information. So let's do another example, because in statistics we're going to see a population does not necessarily mean people. So in English, population is like the size of a city, is how we think of it. How big is a city? It's 80,000. That's the population of the city. Okay? Or we might think of it as the people in the city. But in statistics, it has a much more general meaning. It's all the observations you're interested in studying. So in a particular study or in a particular decision you're making, the population would be all the possible observations. Okay? And so it doesn't have to have anything to do with people. So for example, a variable might be lifetime of batteries. Okay? Now we're not even dealing with people. The lifetime of batteries. So that's going to vary from battery to battery. Different batteries might last a little more or a little less than other batteries. Okay? But the variable is the lifetime. So the data would be specific lifetimes. Okay? And you would have to get this by actually observing. Plug the battery into a little flashlight or whatever and turn it on and see how long the battery lasts. Okay? And you get the lifetime of that particular battery. Okay? And the population would be all the batteries that the company produces. You're interested in the lifetime of all the batteries. So a data set might be the lifetime of 50 randomly selected batteries. Maybe you're going to just test 50 batteries and see how long they last. Okay? Well, that would generate a data set with 50 values. Okay? So here's a couple examples, and maybe you can come up with your own. Come up with some variable someone might be interested in. What would the data be for that variable? And then what would a particular data set be? Okay? Involving that variable. Okay? So when we do statistics, then we're trying to make decisions based upon data. And data comes from observing the value of some variable, which is just something you're interested in, and it varies from person to person in a population, or from battery to battery, or whatever your population is. It doesn't have to be people. Okay? And then the data set is a related set of observations, like all Hawkeye students, 50 randomly selected batteries, whatever generates that data set. It's a particular set of data that you're interested in. Okay? So now let me give you an example here. Let's say you're a researcher, you are interested in college tuitions, and you've been doing a study on college tuitions, and you requested this here, and you probably can't read it. There we go, now you can. The data you requested here on U.S. college tuitions from 1993. Okay, well, let's look at this data and let's see. Let me zoom out here. Oops, I need to focus this again. Oh, sorry. Oh, there we go, perfect. Okay, so let's look at the data here. Let's see what we learn from our data. Okay, we're very excited. We've been waiting for this data. We're very interested in what it can tell us here. So what does our data tell us? Let's see. Boy, there's a lot of numbers here. Boy, this is like page after page of numbers. Like this, the data does not tell me very much. Okay? It's just a whole bunch of numbers. So we don't necessarily learn a lot just from data, okay? And this is actually not that big of a data set. This is only like I think there's about 1,250 some values in this data set. And it's the number of colleges, okay, where they gathered these tuitions from. What if you had 20,000 values or 50,000 values? Then you would have a book, page after page after page of just numbers. Okay? And like that, the data doesn't tell us very much. Okay? So we need techniques that allow us to take this data and organize it and summarize it in such a way that we can make sense out of what the data is telling us. And that is the first branch of statistics that I mentioned earlier. Okay? It is called descriptive statistics. And I forgot to mention, you might want to actually, using this example, can you figure out what the variable would be, what the data would be, and what the data set would be for this particular example, okay? Okay, so back to where, we're going here. Descriptive statistics here. This is kind of the science of collecting, organizing, summarizing, and displaying data. Okay, these are the techniques where we can take that huge data set and organize it in some way to help us make sense out of the data and possibly even display it, some sort of graph or chart or table. Okay, so descriptive statistics involves charts and tables, graphs, histograms, averages. I don't know if you've heard of the mean, median, and mode. Those are types of averages. Standard deviation. This is a very important number we're going to learn how to calculate later. So if you've never heard of it, you don't have to worry about that. But these are all examples of descriptive statistics. And so what you want to do is you just want to think describing the data. So in descriptive statistics, all you're doing is just describing it. So that's where the descriptive comes from. So here's our huge data set, okay? And this is actual data. I took this off of the internet, okay? And I got it as an Excel file off of the internet. And so what I did is I actually loaded all that data into Microsoft Excel. Okay, and Microsoft Excel, if you're not aware of this, it's a very powerful tool that can calculate a lot of the statistical calculations you need to do in order to do statistics. And so you probably, even though you didn't know it, have a program on your own computer. If you have Microsoft Office, you got a program that can do statistics. And so what I did is I put all that data in there, and I first had it find the minimum value. So the minimum tuition is $480, and I had it find the maximum tuition, $25,750. So just the minimum and maximum numbers tells us a lot about that data set, okay? And it would be hard to find those. I'd have to go through all these and find out which one is the minimum and maximum value. That would be very difficult to do, okay? But Excel did it in a second, okay? So what this means, I know all the values now are between those two, and that is helpful. That gives me some information about this data set I did not already know. So another important value is the average value, and that means you're adding them all together and then dividing by the number of values you have, and it just averages it out. So on average, the college tuition is $7,807.27. So that's kind of where it balances out. They're around $7,800. Okay, very useful, helpful information. And then the standard deviation is $5,348.16. And that tells me how spread out the data is. Okay, how on average, how far away from the mean. So the average is kind of like the balance middle point of the data. The standard deviation tells me on average how far values are from the middle. Okay? And like I said, you don't have to worry about that. We're going to talk more about it when we get to chapter 3. Okay? But these are numbers that summarize my data set very nicely. And they give me information that I did not already know about my data set. And like I said, Excel, if you have a data set that large, Excel becomes a very, very useful tool. These values could all be calculated in about a second. Even the standard deviation, which would have taken hours, if not days, to do by hand. Okay? So that's part of descriptive statistics. These are called summaries, summary statistics. They're numbers that describe our data set. Okay. Another thing we could do is we could organize our data. Okay. So this would be like summarizing our data. Organizing it would be, let me zoom in on this table. This is called a frequency distribution table. Okay. I know all the tuitions go between 480, 25,750. Okay, but this is the breakdown. And so what I'm doing is I'm going from 0 to 2,499, 2,500 to 4,999, 5,000 to 7,499, and so on. So I'm splitting it up into intervals that have a width of 2,500. Okay, and I'm doing it from the beginning to the end, so that all my values belong in one of these. These are called the classes, okay, these intervals. And then the frequencies are the number of observations in each class. So you have a lot of observations, 316 between 0 and 2,499. And then 169 between 2,500 and 4,999. 116 between here, and so on down the line. Okay? If you add up the frequencies, I get the total number of values in the data set. So there was 1,272 values. Okay? But this gives me the distribution of my data. It tells me how it's distributed over the range of values. Okay? And then what I can do is, using that table, I can make a histogram. This is called a histogram. And what I do is I have my classes along the bottom. Okay? And then the height of each bar tells me how much data lies in each class. So this is an example of how I could display my data for someone else, and they can see how the data is distributed. Okay? So these are all examples of descriptive statistics.